Alright, hello everybody, hello from your favorite artist electronist, Mr. Q12. I believe I managed to push this entire project to its limits, to its maximum limits, and I fucking did it. I fucking did it. I don't believe I fucking did it, but I did it. I stayed one night. Well, this is the events, how it happened. I took a break of 2 days, doing absolutely nothing. I did whatever I wanted, just to calm my mind and my brain. And this morning when I wake up, I jumped directly into the programming. It means 2 o'clock in the morning last night, and I stay all night until morning when the day is coming out. And right now it is morning and the light come out. And I have no idea how many hours. Probably is, yeah, right now is 9 o'clock. Yeah, something like that, like 7, probably 8 hours in continuous programming. But I did some very cool progress. Let me actually I actually finished the project. All that I put in my mind to make, it is made. I resolved all the problems with the rotary encoder, the problem adding the numbers to the rotary encoder function, and also adding the RGB PWM function to the rotary encoder bigger function. It is a mess. So this is how is behaving when I'm rotating the knob. I had to start everything from 255 because, like I already mentioned, this RGB LED is a common anode. Is inverse from the normal, so to be reset it needs to be at 255 and counting towards 0. So I had to do the same thing not only in code but also in reality to these LCDs. And I also implemented a function of pressing, and when I'm pressing once it will switch between all 3 LCDs. So now when I'm rotating is actually showing there and actually changing the color of that LED. Let me actually press it again. And now it's the blue color, but as you can see, yeah, it's transforming itself into white. It's starting to get more bluer, and it's also pulsing because green and red are weird. They don't combine very well. And I also implemented a function of long press, and when I'm long pressing, it's resetting everything, and it's doing that. It is opening this LED on pin 13, actually, on Arduino, is corresponding to that pin inside there. It's the same link, is the same wire to both of them. You see, if I'm pressing, is opening that as well. It's resetting everything to 0, actually to 255. And when I'm rotating, it retains the position, the last position, which is okay. And now when I'm turning the knob on red, let me actually turn it very low, like this, 254 to green. And when I'm doing it, you see the green is, my camera is not catching it, but in reality, my eye is actually catching a very vivid green there. Quite, yeah, you see, it's very green, but yeah, okay. And there is the blue right now, but my camera is not really catching. It's kind of blurring what I'm getting there. I should find a way of making a micro camera inside there to actually catch each individual LED when it's lighting up. With all this functionality, what you are seeing here, the project is actually finished. Yeah, it's having very minor bugs. By not opening the LCDs when I'm resetting, it is actually shutting them off. This is a minor bug. And also retaining the position, and when you turn the knob you don't know where you are. I was thinking to add a counter and to count 1, 2, 3 to actually know exactly where you are. So a single signal pulse from my microcontroller to a tiny counter that is counting towards 3, and when it's reaching 4 is resetting to 0. Like my favorite 4017, and I was thinking as a very cheap, you know, not to use too many pins from my microcontroller. So pretty much that's it. This project, it is functional. It is doing what I wanted to do. Right now I'm opening only red and blue color and creating a magenta without the green color. And right now I believe I am on the blue. Yeah. So as more I am giving it, the more it is giving me. So let's see. Theoretically I should get to 0 to have the maximum intensity. And I have to turn here a lot. I did this in reverse from 0 to 255 like a couple of good times. Now is absolutely on the maximum. I know for sure is on maximum. And let me switch to red. And now when I'm adding the red, the color will transform into a magenta. Yeah, you already can see it on my finger. In reality, I can see with my eyes 2 distinct colors. The blue color LED, like a tiny little dot, and here the red. But the red is more towards magenta. It's actually combined. It's not that red. Now it's getting into better intensity. I believe it will overwhelm. Yeah, it is overwhelming the blue when it's at the maximum. The red is very powerful. It completely overwhelmed everything. I believe probably this chip, this specific RGB LED, it needs different resistors per each LED, different values, a slight difference from the resistor values to actually calibrate the intensity, especially for the red LED. Because how I did it right now, I put the same value for, I did put 3 resistors, but all the same. And maybe if I can tweak the value of the resistor that is going into red, maybe it will actually balance the RGB LED. This is the problem, the real problem. Maybe it is creating orange and yellow, but more proper resistors, not as it is right now. Although I'm not sure. I was thinking about it, but I'm not very convinced if it's that true. But maybe there is. It must be some sort of balance between these three colors. I start to think maybe this is the cause. As you can see, it is doing the PWMing very well actually. What I'm doing here, and I'm not cheating with anything. So now I'm adding the green, but I'm not sure how. No, on the maximum for the red is not doing well. So let me bring down the red. Somewhere around 100, maybe 120, like that, 130. Now to add the green, let's see. And it's becoming more white. Right now it's actually a bluish white, but it's quite a good white, cold white. It's not a warm white. And now it's getting a greenish white. 120. Okay, and the blue is on the maximum there, and it's quite a good white, but in reality it's a bit towards green or blue. I cannot be sure. Maybe blue because it is on the maximum. It should be more bluer right now, but let me bring down this one. So blue, I'm turning it down. Also to 120 there. And now it's very green. So green is the most powerful in this situation. I'm not sure why. It shouldn't. It should be more clean white, but it isn't. Yeah, you see it's pulsing, the red and green. Anyway, yeah, project finished. I am pleased. Let me reset it. I am pleased with my achievement. I am very pleased because I could push it to this limit, and it's quite an achievement. By the way, this is a very extraordinarily good project for learning and to present your skills, what you can do, and to brag. You know, I like to brag with what I can do, and it's a good way of showing what you can do. And I'm advising everyone that is looking on my videos to start and think for yourself how to do it. You get an idea how I did it, but as a reference or as a guidance, you know, we artists in traditional school, art school, we are taught to use references all the time. Use a reference, look at it, and copy it, and then after you copy it 100 times, you start to remember things, and you start to do it from your head. And that's the process. That's the only humanly possible process. Otherwise is bullshit. And also this is my, let's say, it's like a blueprint, the way I did it, but it's not really that good of a blueprint. But you get the idea how to push it, what is necessary, and how many errors I encountered, and I had to pass over them. And if you get into errors, remember Mr. Q12, how many tens and hundreds of errors is stumbled over to get to this stage that I am right now. And yeah, it was quite a ride, but I'm very, very, very happy right now that I finally make it. The code, I will make it public, but be aware, it's very, very dirty code in the sense that it's having a ton of testing functions in it, and you have to sort and filter whatever you need, piece of code you need from there, you have to clean. I'm thinking to create another file, a new code that is very, very clean and without any kind of testing functions like this one that I'm having right now is, or the others that I had before. That's an idea, but I'm not sure if I will actually do it because I'm done with this project. I'm tired of this project. It was very, very hard. It was out of my way of doing things. This is not what I'm doing usually. What I'm doing usually is way less complicated than this. This was quite over my ears a little bit, and I had to push it extra hard to reach this level, what you're seeing here. I'm very happy that I managed to accomplish it, and it wasn't easy. It was quite hard to make it, and it doesn't matter how hard it is. This is another point I want to transmit. Doesn't matter, really doesn't matter how hard it is. What it matters is if you want it, if you really, really, really want it, you can do it. This is all that I want to say and to transmit to you, is your will to accomplish things, no matter how hard they look at the first glance. This kind of projects, like this project, what I did here, it will tell you how good you are and how advanced you are. And if you can do this kind of projects, you are good enough. And in the same time, I'm bragging myself that I am good enough. This was a bit wild, hard and wild, but it's glorious. It is a glorious project. It is a good project that I finished it. I'm very happy with it. That is working. That's the whole point. And it's working okay. It's working good. Let's add a little bit of green here. The color is starting to pulse. I don't remember, I believe cyan was green and blue, I believe, no? So, let's see. Yeah, I shut off the red. Now I will bring more blue and make that cyan color. Yes, that's it. This is it. So as you can see, it is actually combining quite nicely between green and the blue. I hope in the future, if I will do more experimentation with this RGB LEDs, these types that I'm having here, I hope I can find the problem with the orange and the yellow. And if I find it, I will add it and repair this one that I'm having right now. I hope I will. Let's see. Ready? Yeah, you have to push the limits here. Yeah, it's pretty. It's a very pretty blue actually. But I'm having that very nice blue. All right, pretty much that's it. Let me reset it. Pick. Okay, let me bring up a color to leave it with a color not as close as it is right now. Let me actually bring like that, and a little bit of yeah, not yet. Like that. Yeah, to leave it with a nice color. Open, like that. Move aside, please. And let me very quickly discuss the code. I did a ton of shit here. I don't know where to even begin. I find this guy Friendly Wire. This dude code, I find it. Followed his links. It got me onto this page, which is pretty long actually. You see, he's having everything is discussing on that YouTube video here on this page. And here on the end of the page is actually having the entire code. It's having a very stupid page margins that you cannot actually see the rest of the code. So I had to copy his code from here. I was forced to copy it to be able to read it, not test it. I didn't test per se. I didn't run its code. Only copy it from that page and I put it here in this file, which is a text file by the way. It's having a .txt at the end, and usually an Arduino file is having this Ino extension. This guy actually, or at least his code that he is presenting there, it helped me quite well, but it was a very peculiar issue, an error, this one. The code that I find it in this PDF like I presented it last time, this one, it worked perfectly on the breadboard. So I created a new project and I've added, I believe this was the one, I've added everything, all that code that worked on the breadboard for the rotary encoder and for the RGB. I bring it into this project, and when I run it, I got exactly the same errors as I was getting before this last experiments on the breadboard. On the breadboard worked absolutely perfectly. Here in this project, it didn't work properly at all. I was getting the same glitches. The numbers on the LCDs were running by themselves very fast, or they were glitching. The rotary was actually jumping a lot. Then I find this guy on YouTube, this happy guy here, and I looked on his code. He is actually mentioning that the rotary encoder is making 4 steps, and he is actually decoding those 4 steps. Here I'm having some parts of the old codes, but here is the new rotary encoder. It means this code, I didn't actually copy it all, the entirety of his code. He's actually using, well, he's actually using his code inside an interrupt. Yeah, you see here. So this code from here, I had to fish them out, the code from inside those functions, and insert them into my functions that are not using interruption at all. My functions are using button presses mentality and philosophy, because with the interrupting function you are limited only to those 2 pins, 2 and 3 I believe it was, from Arduino Uno and from the microcontroller itself. But with my method you are not limited. You can use whatever GPIO general pin in out you want from the ones are disponible, including the analog pins. As you can clearly see here, this is pin A is linked to R2, R3, R4, which are the analog pins, and this is from the rotary encoder pins. I have a ton of discussions. What I did, I made a new setup where I set them as these pins as input. By the way, in this configuration, in circuit serial programming modality that I'm running it right now, my microcontroller, this serial is not working at all, and I'm getting a ton of errors. Let me actually show you. These are the errors, some of them. 1, 2, 3. You see, this is not the same with this. This is different. Yeah, you see, I'm getting a ton of errors when I'm trying to run this serial protocol to watch on the serial monitor whatever is telling me. So I'm getting a lot of errors. When I'm having the Arduino Uno connected to the breadboard, this serial protocol is working flawlessly, but in my configuration, what I'm having here in serial circuit programmer is not working at all. But it's not really that big of a problem. It's okay to not have it. It's okay, but it was interesting to actually have it and working. It was a bit more easy. I had to test, instead of this serial monitor, because it didn't work here, I had to test it with LEDs, with the LEDs on the board. It was an extra hard thing to do, but it worked. Yeah, this is the code from that guy that I borrowed. This is his function. This function converts gray code into binary number. I have no idea what it's doing there, but I put it here and I'm using it where it needs to be used, and that's it. It's only here is used. When this position integer, you see it here, this variable is equal with this thing that is converting. And then this position is used somewhere else. Here, specifically here is to be computed. It's a ton of code. I don't know how to even present it. I have no idea how to present it. It's a ton of shit here. Yeah, this one's. So this counting test G and counting test G inverse, I was using them originally to display on the LCDs the numbers, but I faced the reality that I need them split. I was forced to create these three functions. Lucky me that I know my stuff, and I made one single function that is dealing with the first LCD for its three numbers that is displaying on the first LCD, and is for counting up, then to count down. And that's all that is doing this LCD1. This is for LCD1 counting. The same is for LCD2. And let me show you, because these are different. If you are paying attention here, number 1 address 0 for LCD1, but for LCD2 is number 1 address 6, and for LCD3 number 1 address 12. So I had to pay extra mega attention what is what. And also here is incrementing. You see this number 1 increment there, and there, but here is decrementing there, and here. And I also had to pay extra attention to these tiny little details, not to fuck it up. I was very careful with these three specific functions. I didn't actually test them as I'm usually testing them. I make them, and then I jumped to other parts of the code that I needed to solve them. And after I solved those parts of the code, then I could actually test these new functions that I made. So it was extra hard. If this was not behaving as intended, holy fucking shit, I was screwed if I didn't make them good from the first try. And lucky me, I did make them from the first try. So I had to pay extra mega attention to be very careful what I'm putting there. And it worked. I probably correct them 1 or 2 times, not that many times. So this is a small function, rotary switch. And this is when I'm pressing the button on the rotary encoder. For a very long time, it had only this internally, only this code, not this. This is the last code when I struggle a bit, actually, to find a way of making that long press. And if you are reading this comment, it's saying that this part of the code is for the long press button and is working like this, meaning this MSK variable, which you can find it here. This is the variable declared outside of this function. So it's incrementing here. And as you can see, these little notes here, 1, it means 1 millisecond, 4, it means 4 milliseconds, and so on and so on. So if milliseconds is greater than 4, originally I made this MSK variable as 4000. And it didn't do anything. And then I lower it until I reach this crazy number of 4, and it worked after 4 seconds, like that. Actually, it's not 4 milliseconds, actually are seconds there, or very close to those numbers. I'm not completely sure how exactly, but I really don't care. All I need is a little bit of time. As I'm keeping my finger pressed on the button, it is doing the job. So this was the last cherry on the cake, and I believe it's working like this because I have some active delays, most probably in the loop function. So this rotary switch is actually called here is called. The rest of the code, what you are seeing here, are comment out. So they are not actually working. Only these 2 functions are working. They are looped. Yeah, I have a ton of little shits and little details to explain. I cannot make this easy to follow video, unfortunately. I will only point very specific problems and the solutions that I find. That's the story about this part, what is doing and why is working, like I write it here. Here, reset this variable, and if this LED 13 is high, if I'm retracting my finger while that LED is high, I want it to get low. These are little bugs that I observed, and I could deal with them. And also, of course, when it's getting low, here is resetting this variable, resetting the actual RGB LED, and reset to 255. This is a new function that I had to create. Yeah, you see here, this code will turn off all the RGB LEDs, setting them to 255, which is 0 volts in that chip. This is clearing the LCDs, and here I'm setting, or rather said, resetting to 255 the LCD display. And this variable, I took it, as you can read here, is all these variables are from the inside of LCD1 count, these functions here. So I had to take out. So you see it, this is the variable that I'm incrementing it here inside this. But this variable is actually declared somewhere outside, somewhere here. Here are all these variables that are declared as public variables outside of that function. And let's see where I was. So these are those public variables that are used inside, and I can actually reset them to whatever value I want. This kaka1, kaka2, kaka3 are new variables, are these variables here, and I had to reset them as 255 as well. And I have a new very nice kirikiki. So kaka1 equal with kaka2 equal with kaka3 equal with 255. These kaka variables are used in this rotary encoder code. You will see it in a second. And reset RGB, it reset the actual RGB chip. This function reset to 255, specifically to 255 to be off, to keep that RGB off. And next is the actual rotary function. Look how beautiful it is inside. So is this from here until here. So it's not that long, but it is a little bit of stuff in it. So inside this rotary rotary encoder code, I had to deal with the RGB LED, with the LCDs counting up and down. Holy fucking shit. And it didn't work for a very long time, but I was getting hints. This was very helpful from that guy code. He actually didn't use this way of coding, but this is his variable that he is using, this V variable, which I have it somewhere here. Here it is. This is his variable, but this part here is not in his code at all. This function that converts the gray code of the rotary encoder into the binary number. And here are the output. This is the output. Return 0, return 1, return 2, and return 3. And what I did there, I am using it in his code, this, but I had to use it here in my rotary function as well, this conversion. What I did here, I did a very smart thing, but I wasn't sure if it will work. I just tried it, and it did work. And I wasn't 100% sure if it will work, but it appears it is working very well, actually. Is checking if it's divisible by 4. By 4 until it's reaching 0, then get inside this code that is inside. So pretty much what I'm doing here, I'm telling the chip to make abstractions of the 4 jumps, the 4 ticks of the rotary encoder, and instead of counting 4 times as I was rotating 1 time from my rotary encoder, on the LCDs I could see it, and also on the RGB LED I could see the red LED was lighting up 4 times. So what this is doing is limiting to only 1 time the travel. When I'm turning the rotary encoder 1 time, this will actually count 1 time as well. And I did get some errors from this code as well when I originally tested fragments of this code when I was building it up from this guy code, and it was indeed counting to 4 every time I was turning the rotary encoder. Right now, after all this trouble and all this experience that I had until this point, I start to think that my older codes that I created them, when they were making that double or triple or 4 times lighting the LED when I was turning the rotary encoder, that's actually a normal behavior of the rotary encoder to create more steps. And I was interpreting them as an error, but that's the normal behavior. I didn't know that little detail. But now I do. After this many codes I tried, I'm starting to see it as it is. You have to convert, like this guy is saying, to convert from the steps that rotary encoder is throwing at you, to convert those into manageable code, to actually make it look or understand that is only 1 turn. This line is very, very important to do exactly that, to bypass all those 1, 2, 3, 4, 1, 2, 3, 4 every time I'm turning 1 time. Now, kirikiki. The kirikiki variable, when I'm pressing the button, is jumping between the 3 LCDs. This is all that is doing, is incrementing here. And when it's reaching number 4, then it's resetting to 1, meaning the first LCD. So it's first LCD, and why not 0 and 1 directly? Because it is actually called here when is the case, when it's case 1, case 2, and case 3. And when it's reaching 4, when it's incrementing, when I'm pressing this button and is incrementing, is reaching this line, is checking if it's 4, and it is, and then is resetting back to 1. This is all the cases what is doing to switch between the LCDs. So kirikiki is the LCD switching variable, pretty much. And then the kaka variables, kaka 1, kaka 2, and kaka 3. You see them here. This is for case 1. It means for the first LCD, only kaka 1 is incrementing. For the second LCD, only kaka 2 is incrementing. And for the third LCD, only kaka 3 is incrementing. Actually, I was coding them with off, but this remained. This is not actually correct anymore here, so I can erase them there, and also here. So I was keeping them as 0, 0, and only lighting up only 1 color. And then I realized when I was switching from one LCD to another, or from one color to another, it was actually resetting the other 2 colors and only dealing with only 1 that I was leaving it. So then I had to think about it. And I realized I have to keep these variables everywhere in all these 3 cases. And it is doing exactly the job that I wanted to do. And this is calling LCD count 1 when it's counting up. So this LCD count up and down is counting this part when I'm putting here a 1 is counting up. And when I'm putting a 0, when this variable here is 0, is then is switched to this side. When it's counting down is decrementing. So this is when it's called, this function is called from here, from rotary encoder function. Pretty much I'm calling that LCD counter to display on the LCD the numbers and count them up as I'm incrementing this variable. This kaka1 variable color set is actually the PWM special pins on Arduino on Atmega 328. They are special pins that are dealing with PWM to lower the intensity of each LED, of red, green, and blue LED. And this is the function that is doing that. So this is for red, this is for green, and here is for the blue. And then when I'm turning counterclockwise, rotary encoder the other way is doing it inversely. LCD count function is having a 0 here instead of 1, so it's counting down. I also mentioned it here. And here this variable is counting down to actually lower the intensity of each LED, of this specific LED actually. This variable is dealing only with this variable. These 2 are maintaining the same intensity and is working as it should be. And this, I did copy it from his code and I leave it like that because it's good to have it there. I will think about it, what is doing more exactly. exactly in other times. This is it in a very short summary of what the fuck I did here. This project is actually finished, and I'm very, 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 very glad I finished it. Now, part 2 of this project, I was thinking on these ideas that I will expose them right now to you. So I was thinking actually to make another button somewhere, to add a new button that will switch between so this is crazy, between the more crazy than what I did already, but a new button that will switch between these 255 values that are displayed on each LCDs for the intensity of each LED of this RGB chip. So when you press that button once, will show these values. Yeah? But when you press that button again, will actually show the voltages of each LED. So when you press that button, it will show 1.06 or something like that, which it means the voltage that is actually coming or going into that LED, into that specific LED, the blue one, the green one, or the red one. How I thought of it is to make a table and to convert each value. So 255 will be converted into the voltage value. And I will switch between two tables, this table which is having these intensities and that other table that will have the voltages. That's the idea. And the voltages, I will actually measure the voltage on each LED for specific values. I will not do it one by one, I will do it probably 10 by 10. And I will collect like 25 values or something like that. That is one idea without using any hardware reading component, extra complication that is too complicated already. That's one idea, but I really don't want to do it because it's already very complicated, and maybe later when I will be more older I will do it, not right now when I'm still young. What other funky idea I had? That counter to add a small counter and a single pin from the microcontroller to clock that counter IC. And that counter will display on 3 LEDs. Probably I will drag the wires to the LEDs in the line with these LCDs, and each LED will lit up per which LCD is selected from the knob when I'm pressing. Because right now, when I'm pressing this button, you have to pretty much to guess which LCD is selected. So that will be an interesting update or upgrade to this board. But again, I don't want to make it. It's not that much of a deal, big deal. But the problem is that I don't have that miniature counter chip. I have to actually command it from AliExpress. I have to pay money for it. It's not about money because they are cheap. I only have big, deep versions that are very, very big. And I really need small things here, SMD packages. The smaller the better. It's a bit more complicated to add it. I cannot do it right now. If I was having that chip in my possession, I was thinking actually to implement it, especially right now when this project is finished in this stage. That was the idea. After I will finish this project exactly at this stage I am right now, I was thinking to add those two upgrades, or at least one of them. And I was thinking on another cool upgrade to add, but I don't remember what it was. Or if you have more ideas yourself, you can tell me. Another point is that, check this out. If I'm opening this image here, I find this another rotary encoder. I actually got the idea to search for a driver that is dealing with the rotary encoder issues, because I was getting that repetitive output from it, like 1 2 1 2 when I was turning only once. So 1 2 or 1 2 3 4 even. And I was thinking maybe there is a driver chip that is dealing with the rotary encoder to give me only 1 pulse per 1 turn of the knob. That was the problem that I faced a lot in all this project. This was the biggest problem that I had all the time, the majority of the time. And I searched on internet, I got into some forums, and on those forums I've read some discussions, and somebody is pointing to a website, and when I'm going to the website, it was the SparkFun website, and I got onto this thing, and when I'm looking through the pictures, I'm getting on this page, which didn't have this thing or that thing or this thing. These 3 things I've added them myself. And also on this page as well, I've added this title and this price. And only this one single board is $25. It's very expensive, very, very expensive. And I was very curious, what the fuck is that controller, rotary encoder controller? What is its name? And if I'm going, I'm not sure, too close to it, it is very, very pixelated. But if you are looking from a certain distance, you kind of guess it is 80 tiny 8 or 344, like that. This is how I can read with my eyes. And then I searched on internet for other versions of AtiTiny chips to see something that is similar in shape and form with this ones that I'm seeing it here on this board. And I find this guy and I copy it and I put it here in this image. So pretty much what this guy did here is kind of what I did because I used A328, but he is using this other chip also from Atmega, AtiTiny 44A, which is a bit weaker microcontroller, but specific for this function to decode and to transmit a clear signal from the rotary encoder. It's perfect. I believe this is a genius, super genius idea to implement and to use this kind of tiny microcontrollers. And I was thinking, I was looking on them, on their prices, and they are not that cheap, but they are cheap enough. For 20 pieces, I find the price on AliExpress to be around $15, which is quite good for the price. For 10 pieces, I find like around $6, something like that. And I was thinking to add them in my collection, and I will add them in my collection actually. They are in plan. In the same time, while I was looking for the prices and I was looking on AliExpress, I was thinking with half of my brain that I already have some PIC microcontrollers, 12F508, and I can use them most probably specifically to decode this rotary encoder rotation and to spit out one single signal per one rotation that is performing, not more than one, like it's usually doing when it's naked, like I had it here with a ton of problems all the time. This is a very, very, very interesting idea, but I will think on it. I will contemplate on it. This is another upgrade or add-on for a later project with rotary encoders, most probably. But is an idea, is a good idea to keep in mind that you can switch to a hardware component that is doing it specifically extremely well for you without all that coding mambo jumbo that is in my save file that I just explained. All right. Probably this is another upgrade, but it goes without saying, a little box. If you remember, like I originally planned in my 3D sketch that I did it in 3ds Max, if you remember, I did a box, and this thing was going inside the box with a lid. And if you remember, I was planning for all of this to be a pyramid shape. And probably the next version of this project will be that pyramid with that RGB on the top of the pyramid. That will be glorious. That will be very interesting to see. That's probably the third upgrade that I will add. Some sort of casing of boxing. But again, I will see if I will actually do it. This project took me a couple of months to make it. Not because it's very hard to do it. It was having some hard points to deal with, but I didn't have the heart to stay over it, to do it every day. That was the reality. Yeah, I wish I can concentrate more on these types of projects and electronics, because they are the future. This is how people should do electronics in these modern times, not wondering about burning a resistor or burning a transistor or a capacitor and saying, wow, what a miracle. The technology of the smoke, of the smoking component. I cannot believe it. I cannot understand it, why it smoked. This is the end of this project, pretty much. Although I have those upgrades in my mind to add, very small chances to actually implement them. So at this point, I'm calling this officially project terminated, project finished, project done. From this point on, I can take out this XSP plug and all its wires. I can take them out from this board and leave the board without those wires, only with the power wires, and power it and play with it, and that's it. This will become a standalone project in itself without those wires anymore. And I hope you like this project. I hope you understand how hard it was. It wasn't easy, but in the same time, I'm presenting how hard it is, but in the same time, I want to not to discourage you, for you to try the same things I'm trying. So even if I'm showing you the hard stuff, you should not be discouraged by the hardness. You should be encouraged by it. At least take with you the idea that it takes a lot of errors to get over, like I did. When you see me, how many errors I'm getting over, how many problems I had, and I had to resolve them by myself, sometimes with the help of others, but mainly and mostly I'm dealing with all the problems. I'm dealing with all the errors. I'm correcting everything. So that's my point, is to deal with the problems. Even if it's a hard thing, keep in mind that you will encounter a lot of shit on the way, and you have to deal with that shit. You have to get over it and solve the problems, each problem one by one, and don't give up. Do not give up ever. I should tell this to myself as well, because I am giving up, not in electronics and what I know the best, what to do, but in life I did give up a lot. So that's a story for another time. I regret nothing. All right, that's it. Thank you very much for watching. Thank you very much for staying with me, and I hope you like this project. Bye bye from your favorite artist electronist, Mr. Q12. See you later on the next projects. Bye bye.